Okay, class, in this lesson, you will be introduced to the Pythagorean theorem, and then we will also establish relationships in two very special types of right triangles. So let's go ahead and get started with the Pythagorean theorem. So the Pythagorean theorem basically states that if a triangle is a right triangle, then the sum of the squares of the lengths of the legs, meaning the length of this side of the triangle squared, or a squared, plus the length of this side of the triangle squared is equal to the length of the hypotenuse squared, or a squared plus b squared is equal to c squared. Okay, so in essence, the Pythagorean theorem says that if this triangle is a right triangle, then this relationship exists. Now, the converse is also true. So let's take a look at the converse of the Pythagorean theorem. So the converse basically is saying that if this relationship occurs, so a squared plus b squared is equal to c squared, then we know that this triangle is a right triangle. Okay, so let's go ahead and apply this to a particular example. So let's take a look at example 1 here. We're going to use the Pythagorean theorem as well as its converse. Okay, so in this problem, we are told that to satisfy safety regulations, the distance from the wall to the base of a ladder, okay, so if you take a look at this diagram, the distance from the wall to the base of the ladder should be at least 1/4 the length of the ladder. So this is the length of the ladder, and this distance needs to be at a minimum 1/4 the length of the ladder. Okay, so from here to somewhere about here. So the question here is, did Drew set up the ladder correctly? Okay, all right, so what we should notice is that the floor down here, the wall, and the ladder create a right triangle. Okay, so what we should recognize is that this angle here is a 90 degree. Okay, so I just drew a little 90-degree symbol here, and this is essentially our triangle right here. Okay, so I've got this in blue, and here is our triangle. All right, so now that I've created that, I'm going to go ahead and duplicate that so you can see. Let me try that again. Let me go ahead and duplicate this triangle. And move it right here. Okay? So that is the triangle that is created by the floor, the wall, and the ladder. And essentially we need to find the length of the ladder as our first step. Okay? So we are told that the height from the floor to the top of the ladder is 9 feet. Okay, so this is 9 feet, and then the base, the length of the base, which is from the floor to the ladder, is 2.5 feet. Okay, so then we need to find the length of the ladder. I'm going to call this C, and if we plug this into the Pythagorean theorem, which states that a squared plus b squared is equal to c squared, this means that 2.5 squared plus 9 squared is going to be equal to c squared. And then punching those values in the calculator, we find that 2.5 squared is 6.25, and 9 squared is 81, and that sum is going to equal c squared. And adding those together, 6.25 plus 81 gives us 87.25 is equal to c squared. And then to find c, we have to take the square root of both sides. Okay, and we find that c is equal to 9.3. Okay, so now we know that c, or the length of the ladder, is 9.3 feet. Okay, Now we have to take 1/4 of that. So we're going to take 1/4 of 9.3, and we will punch that into the calculator and find that the length is 2.3. Okay, so that is the minimum requirement. So that is the minimum requirement. Okay, per the safety regulation. And since the ladder is 2.5 feet away from the wall, okay, so 2.5 is greater than 2.3 feet, which means Drew set up the ladder correctly. Okay, he did a good job in adhering to safety regulations. Okay, so that is how you apply the Pythagorean theorem. Again, it is the length of the leg squared plus the length of the other leg squared, and that is equal to the hypotenuse squared. Okay, all right, now let's go ahead and take a look at one of the two special triangles. And this is called the 45, 45, 90 triangle theorem. Okay, so in this theorem, what this is basically saying is that when you have a triangle, or when you have a right triangle where the legs, the length of the legs are equal, okay, so we have length S here and length S here, then the hypotenuse is going to be S square root of 2. Okay, it is as simple as that. So again, the requirement here is that you have to have a right triangle, which this is, and then the legs, if the legs are the same length, or in other words, both the angles are 45 and 45 degrees, so we have a 45, 45, 90 degree triangle, then we know that the length of the legs will be the same, they're the same length, and the hypotenuse is going to be S square root of 2. Okay, so that's one special right triangle. And then the second special right triangle is called the 30, 60, 90 triangle theorem. So in this theorem, or in this special triangle, the length of the hypotenuse, so this length here, is going to be twice the length of this leg opposite the 30 degrees. Okay, here's 30 degrees, which means the opposite side is going to be half the length of the hypotenuse, and the length of the leg opposite the 60 degrees is going to be this length opposite the 30 times square root of 3. Okay, so let me give you an example. Let's say that the length of this triangle ABC, this is 20. Okay, if you're given the length of the hypotenuse, then we know, based on the 30, 60, 90 triangle theorem, that the length opposite the 30 degrees, so that's length SB, is going to be half of 20, or it's going to be equal to 10. Okay, and then the length opposite the 60 degree angle, so in this case side AC, is going to be this length times square root of 3. So this is going to be 10 square root of 3. Okay, so that essentially are the 3 theorems for this lesson. So let's go ahead and take a look at this next example and determine the lengths of AB and BC for each of these triangles. Okay, so let's take a look at this triangle first. Okay, we are to find the length of AB, or the hypotenuse. Okay, this is one of the special triangles because we have a 30, 60, 90 degree triangle. So we can use the 30, 60, 90 triangle theorem to determine the length of this side. Okay, so we know that opposite the 60 is 28. Okay, it is 28. Since this is supposed to be equal to, let me go ahead, write this down. This should be equal to x square root of 3. Okay, and we know that this is x, and this is going to be 2x, we need to figure out what is the length of this, right? So first what we're going to do is solve for x. So x is now going to equal 28 over square root of 3, okay? And then we have to multiply the top and bottom by square root of 3 because we can't have a square root sign in the denominator. Okay, so we're going to multiply this by square root of 3 over square root of 3, and this quantity is essentially 1. Okay, so we're multiplying this whole thing by a value of 1. So we're not changing the value here. And by doing so, we find that x is equal to 28 square root of 3 over 3. Okay, so then now that we know what x is, then to look for the segment AB, that is equal to 2x. So that's going to equal 2 times 28 square root of 3 over 3. And that works out to 56 square root of 3 over 3. Okay, so that is the length of AB for this triangle, 56 square root of 3 over 3. And then we also need to find the length of BC in this 45, 45, 90 triangle. Okay, so we are told, or we're given the fact that the hypotenuse here is 14. So let's go ahead and set 14 equal to x square root of 2, because we know that by the 45, 45, 90 triangle theorem, this length is going to be the length of the leg, square root of 2. So if I set this equal to, if I set 14 equal to square root of 2, we can solve for x. Okay, so I'm going to go ahead and write this over here. 14 is equal to x square root of 2. And then we're going to divide both sides by square root of 2. So that this cancels out, and we get x is equal to 14 over square root of 2. Again, we can't have a radical sign in the denominator, so we're going to need to multiply the top and bottom by square root of 2 over square root of 2. And this works out to 14 square root of 2 over 2, which simplifies to 7 square root of square root of 2. Okay, so that is essentially the length of BC. Okay, hopefully that made sense. It should be pretty straightforward, but if any of this was unclear, please go back to the beginning of the recording and listen to this again. Thank you.